Hello, welcome back. Today let's try to solve another Leetcode problem, 120 triangle. So we are given a triangle like this. We just need to calculate the minimum path sum. What do I mean by path sum is we're gonna sum from the top to the bottom. For example, 2 plus 3 and plus 5 plus 1, it equals to 11. It is the minimum. But there are also some conditions for the path. So for each step, you may move to an adjacent number of the row below. More formally, if you are on index I, it means for the next step, you can go either I or I plus 1. So this means if you are starting from this first number 2, so for the next one, you can start with 3 or 4. So for the next step, if you are starting with number 3, you can go to 6 or 5 because it is always index I or I plus 1. It means it must be a neighbor from the first to the second. Now let me go to the whiteboard to explain my solution and then go to the code editor to finish the coding. So we're going to use this first example. So we have a triangle like this, and we just need to find the minimum path sum. So this is basically a DP matrix problem. First of all, we should recognize this is a 2D matrix problem. For the 2D matrix problem, when we are using dynamic programming, we should first find some positions or conditions of how can we calculate each of the state. For example, if we are starting from this number 2, it means for the next step, we can go to the number 3 and number 4. We can calculate the minimum. And for the next step, we check this for the 3. If we are starting at 3, we're going to check this 6 and 5. For this kind of top to bottom solution, normally we should define a DP array. So inside of the DP array, maybe 2 is here, 3 and 4 is here. We have to calculate for each of the steps, but this is much harder. And the question also asked for the follow-up question, asked to use ON space. If we use ON space, we can prepare a DP array. So the DP array is just a 1D array. So this 1D array, we can also start from the bottom to the top. If we prepare a 1D array of like the length of the array is 4, so for the first step, we are starting from like 4. We are starting from 4, 1, 8, and 3. And when we go to the next row, because we are going from the bottom to the top, if we go to the second last row, it is 6 and 5. If we are at the position of 4, so what is the updated number? So of course 6 will plus 1 because 1 is minimum compared with 4. So here will be updated to 7. And what about 5? 5 will be updated to 6. And what about 7? Will be because 7 plus 3 is the minimum. Let me write it here. So it will be 7, 6, and 10. And then this is our current state. What is the next state? It is 3 and 4. And then we are going to update this 3 and 4. So 3 plus 6 is the minimum. So here will be 9. And the next number will be 10 because 4 plus 6 is the minimum compared with 4 plus 10. So it will be 9 and 10. And what is our last number? It is 2. So now we just need to compare. Our current state is 9 and 10. We just need to compare with 9 and 10 because 9 is smaller. We just need to use plus 9 plus 2. So it is 11. So what we're going to return is just DP 0. So for the DP0, it is 11. So this is our final result. So this is just use O1 space. But for the time complexity, it is just ON square because basically we're going to use 2 for loops and each loop is ON. So the time complexity is ON square. But actually we don't even need to use the DP array because this last row can be used as our DP array. Now we just use the last row. If we're starting from the 4, 1, 8, and 3, we updated, go to the second position, it is 7, 6, and 10. So this is still our last row. So this is just a O1 space solution. We don't even need to use the actual memory. So after updating, we're gonna update with the 3 and 4. After updating with the 3 and 4, we're gonna have a 9 and 10. Yeah, we don't need to consider other numbers because normally we have this index 2 and index 3, but it doesn't matter because we are not concerning about here. We just need to consider this 9 and 10 and compare it with this 2. After updating, so here will be updated to 11. After that, we don't even need to consider all those numbers. We just need to return this dp. It's not dp, it's a triangle. It's a triangle 0 and 0. So this will be our final result. Yeah, so this is just, we try to use the DP in place. We don't even need to use the actual memory. Yeah, because for DP, it is always for saving the memory. It is like the memory compression. We compress the 2D array to a 1D array, and even we can compress it in place. It is just O1 space. Now let me go to the code editor to finish the coding. Actually, if you understand each of the steps, the coding should be much easier. So first of all, we're gonna prepare a n. N is the length of the triangle. So this gonna determine what is how many rows of the triangle. For example, this is 4 because the 1, 2, 3, and 4 we have 4 rows. So this is the length. Now we are going to use the 2 for loops. So for r in range, so we are going to start from the second last row. It's not the last because the last has already prepared for us. We don't need to update anything. We are going to update from the second last from here. So it is n minus 2 and minus 1 minus 1 because this is from the bottom to the top DP algorithm. So this is for the row. And what about the column? So for the column here, I use say in range. So how many numbers inside the column? As we know, there are 3. So how this 3 is calculated? It is always dependent on this r. So it should be r plus 1. Why? For example, this r is 2 because the index 0, 1, 2. And this r plus 1, it is 3. So it means C has 3 positions. And also for this triangle, it is always, how many rows, and for each of the row, how many numbers, it is always equal. For example, we have 4 rows. The fourth row has 4 numbers. So the third row has 3 numbers. The second row has 2 numbers. So this is why we can use this row plus 1, because in Python, this one is not included. So it means in each row, we have how many numbers? We have the r numbers. So here we just use r plus 1. Yeah, because r and c should be equal. Yeah. Now we just need to update our DP. So our DP is for triangle. This r and c should plus equal to the minimum of triangle. R plus 1, it means from the last row, and how many numbers? There are 2 numbers. So in Python, we can use array slice. So for array slice, we can just gonna start from this C and C plus 2. So C plus 2 is not included. This means it is just going to start from this C to C plus 1. It means these 2 numbers for this number 6. Yeah. Now we just need to return our final result. As I said, the final result will be this 0 and 0. So after updating, this number will be the final result after updating from the bottom to the top. Now let me run it to check if there are any mistakes. Yeah, there is no mistakes. Now let me submit it to check if it can pass all the testing cases. As you can see, it passed all the testing cases and it's pretty fast. Thank you for watching. See you next time.